This is Inspiring Design, where unique innovators come together to share their knowledge, share their insight, and keep us up to date with the latest industry trends. And here's your host, Roshan Senanayake.
What's up, listeners? Welcome to Season 4 of Inspiring Design with Roshan Senanayake. This is where the best of the best brands, experts, change makers, and thought leaders come together to share their valuable insights, experience, and knowledge, all centered around the growth sector in advanced manufacturing within Industry 4.0, encompassing various industries, technologies, skills, knowledge, trends, as well as stakeholders, all the while linking it back into education within schools and universities. What's up, listeners? Welcome to Inspiring Design. Today, we're going to deep dive into the fascinating world of dam engineering, a branch of civil engineering. To speak about this sector, I have here with me one of the leading minds on a global scale, Dr. Gamini Adikari. How would I describe Gamini? Simply put, 43 years of experience. 43 years of an exceptional professional career in dams engineering, in the water resources industry, within the public and private sector. He's worked in Australia, Asia, Africa, and Europe, especially in safety management, technical assessment, design, investigation, and numerical modeling of dams associated specifically with water supply, irrigation, as well as hydropower projects. Not only is Gamini a chartered professional engineer, he also holds a Doctor of Philosophy in Dams Engineering from the prestigious Monash University. The list keeps going. He's a member and fellow at a number of professional engineering institutes all over the world and is literally one of the smartest minds I have ever personally met. So he's the right man for the job. Gamini, welcome to the show. Welcome to Inspiring Design. Can you tell us a little bit of your background? What's your story?
Thank you, Roshan. I graduated as a civil engineer 47 years ago in Sri Lanka, where I was born and educated up to the first degree level. My career in Australia began in 1978 when I arrived here to do my PhD in dams engineering at Monash University in Melbourne.
Melbourne would have looked a lot different back then.
Yes, it did. And because I have been living here, the change hasn't been too dramatic. But for someone who would have visited 47 years later, it would have been unrecognizable.
Yeah.
And dams was the field I always wanted to work in. Growing up as a child, I was fascinated by these large structures and the way they change people's lives for the better in multiple ways. So after my PhD, I took up a position as a dams engineer in the water supply department of the Victorian government. Since World War II, Victoria was building on average one dam a year.
Wow.
And I joined this well-developed dam design and construction program. In the mid-1990s, the Victorian government prioritized the dams group and SMEC bought the dams group. So I have been with SMEC since then and currently work as its Chief Technical Principal, Dam Safety.
Wow. So how long is that career at SMEC?
27 years.
Wow, that's awesome. It's almost, I think, unheard of these days in 2022 where someone would stay for that long in one company. So it's very unique, and I'm sure SMEC has a lot of good things to say about your contribution.
SMEC does. And to give you an example, ever since I started with SMEC, I have had really interesting and challenging jobs that were given to me, and they've appreciated my input. And also recently did a interview with me and put it on the website too. So it's something that
Yes.
I appreciate.
Absolutely. And definitely for those of you listening, make sure you guys go to the show notes and check out the link. This article is well written and directs you straight to the SMEC website's article. So don't forget to check that out. Can you tell us a little bit about SMEC? What do they do? And can you tell us some context about who exactly is SMEC?
SMEC is a large multinational company with a global footprint. And SMEC has 120 plus offices in 40 plus countries. And they're spread across all continents. So so we are one of the top tier consultants in the world.
Yeah, wow, excellent. Well, this is why I actually wanted to make sure that we get an expert such as yourself. And I know schools and universities listening in can actually gain a lot from understanding what these big multinational corporations and how they operate. Before we get into the nitty-gritty of dams engineering, can you give us a high-level information of what exactly is civil engineering?
Yeah, civil engineering is all about making lives easier for people, and it's the engineering that harnesses the natural power of the nature into the benefit of mankind, and that's how the civil engineering was defined a few hundred years ago.
Right. Yeah.
And so at that time, engineering was largely broken up into three main areas: civil engineering, electrical engineering, and mechanical engineering. And so broadly, dams engineering falls into the civil engineering area. And now civil engineering has expanded into something like almost 100 different fields.
Great. So let's get into dams engineering. That's the main focus of today and your principal expertise. Tell us a little bit about what exactly is dams engineering. I mean, I feel like the name is there, but what's exactly involved with it, and how did you know that this is what you wanted to do?
The dams engineering, as the name sounds, is all about dams. And it starts with investigating a site. And I mean, if you talk about a greenfield site where there is no dam existing, then the first thing you would do is do an environmental impact assessment to see whether there are any adverse effects of building a dam at that particular site. So once that's done, you do an investigation to look at the foundations, and then that investigation can be quite extensive. And then you start developing your preliminary design to suit the requirement of that particular dam, whether it is a water supply dam or a dam for generating hydropower, or it is recreational dam or a dam for irrigation. So depending on the purpose for which the dam is designed and constructed, you take different approaches. So once you do that investigation, you do a preliminary design, and then that gives you a reasonable impression of what it's going to cost, and then you go into a detailed design, and then into construction. So during construction, you'll get involved with multiple different contractors. If there is a power station involved, then you would have electromechanical people. If there is a tunnel involved for diverting the river then you would have tunneling engineers involved. I mean, they're all different fields that come into the mix of building a dam. And sometimes you do have a bridge across the spillway of a dam. Then you would need structural and bridge engineers to design that. And then you will naturally have a road over the dam connecting the two sides of the riverbanks. And then you would need the transport and road engineers to be involved in that.
Yeah, well, this is, I think I'm starting to get a picture of what's involved with it. And it's actually a pretty interesting field. And when we actually think about it, take a moment to visualize how big system things that we're not talking about a little bit of water. We're talking about massive almost megatons of water and being controlled in an environment towards a particular outcome too. And it might have adverse effects on the entire city if it's not actually properly executed. And do you know how many dams there are in the world? Just throwing out some crazy numbers.
Yeah, I would say this is actually something that I haven't looked up in the recent past, but there would be, if you look at all the dams in the world, there would be millions.
Wow.
And well, then you look at the dams can be categorized into small dams, then large dams. Primarily, they have this definition of a large dam being more than 15 meters high and certain reservoir size and certain spillway size. And there'll be something like 100,000 of those dams around. Wow. And in Australia, we have about 500 of those large dams. And when you look at all the dams store water in Australia, there is close to 370,000.
Wow. Yeah.
And they have been built for various purposes, as I said before.
Yeah, perfect. Well, let's take a look at what this industry looks like as a comparison point of view of the past and the future. So let's focus on the past for the time being. What do you think your industry looked like, let's say 10 to 20, 30 years ago? How did it look like in terms of practice? And obviously you were part of that journey 27 years ago, entering the industry, especially into SMEC. So do you see a lot of evolution in how dams are constructed over the last 3 decades?
In terms of the way they are constructed, I mean, the techniques for investigation, design, and construction have changed quite dramatically over that period. And over the 40 plus years that I have been interested in dams as a civil engineer, I can see the field changing. The design principles are evolving, and more and more research is being undertaken into various aspects like design of filters for dams and anchors for concrete dams. Things like that are continually being improved, and with those newer techniques for design and installation come through.
Yeah, absolutely. And where do you think, if you had to forecast where this magnificent industry is going to be headed, what do you think it'll look like in, let's say, in the next few decades?
So as an industry, we should not look at just the dam construction. We should also be looking at how the dams that we have already built should be looked after, so that they are maintained in safe condition going forward. So as the sites for new dams become less and less, and the efficient use of water is what people usually are encouraged to do, then we can do with fewer new dams being constructed in the future, but maintain the existing dams in a safe and efficient way. So that is where dam safety comes in, and that's the field that I have been focusing on for the last 30 plus years.
Wow.
And how we should safely improve and maintain these existing dams. Because the dams that were designed and built, say, 50 years ago, were designed and built to different standards and practices. And while they have very long lives, if you take, for example, the ancient dams that you find around the world, including Sri Lanka and other parts of Europe and Asia, they are 2,000 to 3,000 years old. So, but those dams were very conservatively designed so that they would not fail. But these days, as engineers, we make those designs much more efficient and much more safer. So the evolution has been in the way we design these dams to be safe, and we construct them to be more economical and efficient use of materials.
Of course. And obviously with that, I'm assuming there would be a lot of technology involved, especially in the last 10 to 15 years, I think. Do you see a lot of technologies integrated within the actual dams industries in the last decade versus, let's say, pre-2000? And some technologies that I feel like just by logic would come into play would be drones, because you're working with a large site. Usually you would need an aerial point of view, recording things a bit more accurately, and then documenting in CAD. Do you have building information modeling involved in dams engineering?
Yeah, you can use building information modeling, but it's more in an area of infrastructure such as buildings, whereas for dams during construction, because they are uniquely designed for a particular site, we don't use as much of it. But what we do is, when we are in the phase of monitoring and management of dams, and when we do dam inspections to make sure that there are no issues developing, we use techniques such as drones for accessing areas that we cannot access safely, and that way we can send a drone camera out and maneuver it in such a way that we can look at those difficult to access areas to make sure that they're still functioning as they are intended. So that's during the inspections and maintenance area, but during design and construction, likewise, we use new technology now with the use of CAD with the drawings and how they are designed and sent across to the site for construction. And the construction itself, and all the new techniques that have been developed for construction come into play. Although the actual method of construction, depending on the type of dam, whether it is an earth and rockfill dam or a concrete dam or concrete arch dam, so depending on what you build, different machinery and techniques will be used. And so the new technology that comes through in those areas are always coming into use in this field.
Yeah, awesome. And do you see much robotics integrated into dams engineering? Simply, the logic behind that question was maybe in the maintenance of especially the older dams, being able to restore things quicker and more accurately, removing that human error. Do you see much robotics within the context?
No, because the dams need to be designed for the particular site. Then we do use techniques which are specific, and they're not readily implemented from one side to another, except for general principles.
Okay, fair enough. Fair enough. And so one of the things I want to understand now, looking at, we've discussed technology, we've discussed the different avenues that come from that. How do you see, it's almost an obvious question, but how do you see the role of design thinking fall within the context of dams engineering? Now, design thinking can be seen as creative thinking. It could be critical problem solving. There's a number of different ways, but obviously because we're working with dams that are big systems, either towards power generation, or it might be towards diversion, it might be towards retention, there might be a whole array of different big system problems. Do you see design thinking being a key skill set within your industry?
To answer that question, the way you think about the design is to see how things can be made more efficient and safer. So that is the area in which the focus should be made. And when we talk about a dam, we always need to consider what is the what's the best way of making sure that this is safe, and how we can make sure that, in a way, efficient design is it gives that impression that you want to use less materials and faster construction techniques and the like, but that's not how this area should be looked at, given the risk to the population, as well as in other areas where the risk comes in.
Yeah. And sorry, a question came into my mind while you were explaining it. I wanted to know, what's a general, when someone's designing, let's say, a new dam, is there a lifespan that they're aiming for generally?
A new dam is usually designed for 100 years. That's usually, it depends on what areas of the dam that you you focus on, and for the civil components, that's the design life cycle that we use. And for mechanical aspects, like the valves and pipelines and the mechanical equipment that are needed to operate, such as spillways, spillway gates, they are designed to last a design life of about 50 years. And then there are also electrical works that are involved in operating those, and those electrical components are generally designed to last about 25 years, so they're expected to be renewed at those intervals. Although, having said that, the civil structures do last a lot longer than 100 years, and as I said before, depending on the way these dams are built and which materials they have used, they've lasted 2,000 to 3,000 years. 2,000 to 3,000 years, and the expectation is that they should last at least 500 years.
Wow.
But it can be longer than that also.
That's awesome. I think it really puts things into perspective when, especially working with teachers and students in schools and universities, when, generally a design task is, or a problem solving task is very almost immediate. And if someone has to design something for that lasts 500 years, it's almost a different type of thinking, and it puts things into a whole different way of framing. So I love that. Now, linking things back into education, what do you think are the key skill sets required to be a successful dams engineer or working within your industry? What are some crucial skill sets that you look for?
I would say people who have appetite for sort of analytical things. I'm talking about things like science, technology, engineering, and mathematics. So they are the areas that generally come into focus in engineering generally and in dams in particular. Students who do like those subjects are the ones who would be attracted to these fields, and particularly maths. That's where, as students at school, that's what I was good at, and so this is where my sort of natural tendencies was cultivated going into this built environment, and particularly the dams industry. So it's usually the students' own abilities and interests that would generally drive it. The teachers can teach it out of the students to see how which areas that the students are more interested in, and the teachers can also cultivate that interest in their minds by introducing these areas into their classroom curriculum, so that when they are exposed to these fields, they will start to think, oh, that is an area that I might like. So unless you plant those seeds in students' minds, they won't know what's around them. So I think it's the teacher's job, which is actually one of the toughest in my view, because my parents are both teachers, so I understand what teaching is. This is where the interests are forged and the interests are developed. So it's an area that the teachers actually have a particular role to play.
Absolutely, and I 100% agree with that. We actually recently ran this competition. It was a design thinking competition on problem solving towards climate change, and there were the state school. We actually had a whole array of different thinking styles and solutions that came out of it, and some were fully developed games for education purposes. Some were clothing material to raise awareness, or recycled products. And the one that really interested me was the students actually came up with a new style of irrigation system. In their eyes, they were really interested in problem solving that for the school environment, all geared towards the climate change context. So it was really interesting to see how they perceived the same problem, but because of their interest, as you just mentioned, they kind of focus on that level of accountability towards the context they like naturally, and they start to problem solve using those skill sets, science, engineering, mathematics, and so on. So it's really interesting to see those types of seeds actually come into something. So I'm very much in alignment with what you're thinking. Now, if you had to advise students and graduates on, say, anything towards developing their careers or entering and exploring the dams engineering as a possible career, what's your advice for them?
If I can answer this question in two parts. First, for students, as I said, it's actually the teachers who generally have a role to play there. But for the students who aspire to be in these areas, they should be focusing on those analytical fields like maths and science, and then look at what parts of engineering that would interest them, because it's such a huge field, and then they can pursue their career in that direction, and then they could choose the university courses that they would like to do, and also select the subjects in VCE and HSC to allow them to go into those areas. And then secondly, when you are in the universities, the university teachers do have this role of teaching them the principles and techniques in different parts of engineering, so that they go into the industry as industry ready. So in that particular circumstance, the most important aspect that I see is that the students need to be given a thorough understanding of the fundamentals of engineering in their chosen fields, make them conversant with the first principles of engineering in their fields. They need to use examples where those fundamentals are used, and that way they'll get to also familiar with how these principles use and how things work.
Yeah.
So it's only if you understand how things work, you can step out of the box and look at new way of doing things and make the processes more efficient, as well as safe in our world of engineering.
Absolutely, and I think that's valuable advice. Now, lastly, you've already mentioned that your parents were teachers, so you would have a very unique outlook on the role of a teacher. And personally, something that I constantly say is teachers are highly underrated in Australia, and I think they should be valued a lot more, simply because they're the ones designing the future capital of our society. And teachers have a massive role to play in shaping the minds and their careers and how they're going to contribute towards their future society when students grow up. I know I was affected by a couple of my really, really favorite teachers. And so because of that, the work we do is always geared towards helping these teachers. What's your advice for them?
Yeah, I think at both levels, at school as well as at universities, I mean, they've been given this wonderful asset to develop and nurture, and they do actually have that responsibility to make sure that that they use that opportunity to forge a generation that's well equipped with the tools that they need to go into the society and start using them. So depending on the areas that they choose to go into, so I keep going back to how they should be taught the fundamentals of whatever that area that they choose to work in or study in, those principles and how to apply those fundamentals and first principles. So if you keep that in the back of your mind, they will go out into the industry being aware of how to look at a problem from the perspective of how these things work, and so that way they will be able to dissect a problem and analyze it and find good solutions to those problems.
Perfect. Valuable advice once again. And I feel like we've only touched the surface when it comes to this big field in dams engineering. But unfortunately, that's the time for today. But thank you so much, Gamini, for all the words of wisdom and showing us what is involved with the dams engineering and sharing the knowledge from your exceptional career. This is something I'm very proud of, seeing how you've gone through, and it's really good to see where this exciting field is actually headed. And I think hopefully this episode, listening to what you have shared, we've inspired a few more minds to be the future dams engineers of Australia. So thank you so much for your time.
Thank you for having me.
Pleasure.
That's it for today's episode. Now it's time to take action and build on the learnings to get inspired. First up, jump onto rashansenanayaka.com/podcast and check out the show notes, links, and other relevant learning materials from this amazing episode. Next, if you learned something new today, click that subscribe button and set yourself up to receive live notifications on future episodes, as well as more opportunities to learn from our amazing guests, brands, and speakers. Last but not least, it's time to have your say. Join the conversation and share your thoughts and feedback on today's episode with a review, all while joining many others with a 5-star rating for Inspiring Design with Rashan Senanayaka. Till next time.